This time, I'm going to talk about KNearest neighbor algorithm in Python. KNearest neighbor algorithm is one type of machine learning method. Machine learning methods can be divided into three big categories. Supervised machine learning, that means we knew the results, and machine learning will learn from the dataset. Unsupervised machine learning means we do not know the results. We will let machine learning to learn and let data speak for themselves. The third type is reinforcement machine learning. In this case, algorithm will learn to react to an environment. The K-nearest neighbors algorithm, sometimes it is called KNN algorithm in short, is a type of supervised machine learning algorithm. KNN is extremely easy to implement in its most basic form and yet performs quite complex classification tasks. KNN is a non-parametric learning algorithm, which means that it doesn't assume anything about the underlying data. This is an extremely useful feature since most of the real-world data doesn't really follow any theoretical assumptions. So, how does KNN algorithm work? The intuition behind the KNN algorithm is one of the simplest of all the supervised machine learning algorithms. It simply calculates the distance of a new data point to all other training data points. For example, we have two types of data. One type is a square, another type is triangle. And we knew the triangle data located here and the square data located here. And now we got a new data point. What we need to do is to calculate the distance between the new data point and the existing data point, and try to classify this new data point. And during this process, we need to decide the k, which is a critical parameter for our algorithm. If we say k equal to 1, that means we will classify this new data point to the closest existing data point. If we see a square is the closest data point to this new data point, we will classify this new data point to class square. How about if we decide to use k equal to 3, and then we will try to get 3 closest existing data point to this new data point. So this is one data point, this is another one, this is another one. So among those 3 data points, we have 2 triangles and 1 square. So if we decide use k equal to 3, we will classify this new data point as a triangle, because in this circle we have more triangles than squares. That is, k is very critical to our result. If we take k equal to 1, we will classify this data point as a square. But when we use k equal to 3, we will classify this new data point as a triangle. So what are the pros of KNN algorithm? It's extremely easy to implement, and we saw we only need to calculate all those distances between the data points. The second pro is it is lazy learning algorithm and therefore requires no training prior to making real-time predictions. This makes the KNN algorithm much faster than other algorithms. The third pro is, since the algorithm requires no training before making predictions, new data can be added seamlessly. Lastly, there are only two parameters required to implement KNN. That is, the value of k, as I mentioned before, and the distance function. Then, what are those cons of KNN algorithm? The KNN algorithm doesn't work well with high-dimensional data because with large number of dimensions it becomes difficult for the algorithm to calculate distance in each dimension. Also, the KNN algorithm has a high prediction cost for large datasets. You can imagine if you have one new data point and you have 10,000 existing data points, and then you have to calculate the distances for 10,000 times. And if you have 1 billion existing data points, you need to calculate distances for 1 billion times. Finally, the KNN algorithm doesn't work well with categorical features since it is difficult to find the distance between dimensions with categorical features. Now we knew it is very critical to decide k in our model. When new data points come in, the algorithm will try to predict that to the nearest of the boundary line. If we decide to use k equal to 1, the boundary line will be here. But if we decide to use k equal to 3, the boundary line will be here. So larger k value means smoother curves of separation, resulting in less complex models, whereas smaller k value tends to overfit the data and resulting in complex models. It is very important to have the right k value when analyzing the data set to avoid overfitting and underfitting of the data set. Now let's take a look. How can we implement KNN algorithm in Python, and how can we decide the right k value? I'm going to use flower iris for my model. First, I will download the data from the internet about iris. Let's take a look at our data. We have 4 features for the flower: the sepal length, sepal width, petal length, petal width. And because this is a supervised machine learning, of course, we knew the class the iris belongs to. And this value we are going to use as y, and all those 4 features we are going to use as x. First, we are going to split the data into a training set and test set. And we standardize the scale. In Python, there is a package called KNearest classifier. We can use this for our KNN model. First, we'll import this package, and then we'll try to fit the data with our training set. After that, we are going to use our test data set to test how good our model is. Let's see the results. You can see this time we have 6 data belong to this category, and 12 data belong to the second category, 12 data belong to the third category. And this time we got all correct, so this is pretty good. Because when we generate this model, every time it has some randomness. So if you run it again, you see the first type we got 14, second one we got 9, and third type we got 7. And also this time it's all correct, categorized. If we run it again, and this time we are not so lucky. The first type we got 9 all correct, but the second type we got 10 correct but 2 wrong, and the third type we got 9 correct. This time we used k as 5 as a parameter. So how do we know if 5 is the best number for our model? For this purpose, I'm going to run k equal to 1 to 40 as a loop, and to see which one is the best for my model. Let's see what will happen. This is the result. You can see the x-axis, I have k plotted here. It's k equal to 1 all the way to k equal to 40. And the mean error is plotted on the y-axis. We can see between 1 and 15, the mean error is very low. So our best k should be between 1 and 15. If we run this model again, and this time it will say the best k should be between 6 and 14. Of course, every time you run the model, because of the randomness, it gives you a little bit different results. This is how I build KNearest neighbor algorithm in Python. Please provide your comments and subscribe to my YouTube channel. Thank you very much for watching.